Have you ever been confused by the differences in programming operations? If so, you're not alone. Today, we're diving into a common question about left-shift operations in C programming. I totally get it. Understanding how different assignment operations work can be tricky, especially when they yield different results. You're not the only one who has stumbled upon this confusion. Here's the specific question we're addressing today. A user asked, what is the difference between directly assigning the result of a left-shift operation to a variable and using the left-shift assignment operation? Let's break this down together. To understand this, we need to look at two expressions. The first one directly assigns the result of the left-shift operation to a variable, while the second one uses the left-shift assignment operator. Let's see how these work. And stick around. By the end of this video, you'll not only understand the difference, but also gain insights into how these operations affect your variables. To understand the difference between directly assigning the result of a left-shift operation and using the left-shift assignment operation, let's first look at the first example. Here, the user assigns the result of shifting the number 7 to the left by 32 positions directly to the variable I. In this case, the left-shift operation can lead to unexpected results because shifting a number left by more than its bit width can cause the result to be undefined or 0. This is why the user sees a different value for I. Now, let's examine the second example where the user uses the left-shift assignment operation. Here, the user starts with the variable x, initialized to 7, and then shifts it left by 32 positions. Similar to the first example, shifting x left by 32 also results in undefined behavior. However, since x is being modified in place, the outcome may differ based on the compiler's handling of the operation. In contrast, the last two examples demonstrate operations that yield consistent results. The user adds 1 to both A and B, and both operations are well-defined, leading to predictable outcomes. So why do these two expressions yield different results? The key lies in how the left-shift operation handles the bits and the size of the data type. When you shift bits beyond the size of the data type, the result can be unpredictable. Fun fact, in C, shifting bits beyond the size of the variable can lead to undefined behavior. It's like trying to fit a square peg in a round hole. Sometimes it just doesn't work. Now let's look at the answers provided by other users. In summary, the difference between directly assigning the result of a left-shift operation and using the left-shift assignment operator lies in how they manipulate the variable and the potential for undefined behavior when shifting bits too far. And there you have it. Understanding these operations can really enhance your programming skills. If you found this video helpful, don't forget to subscribe for more insights and tips on programming. This user suggests resolving the ambiguity in left-shift operations by using unsigned long. They emphasize that using ULL indicates to the compiler that the number being shifted exceeds 32 bits. Let's take a look at another answer from another user. This user explains that the difference in results from the left-shift operations is due to undefined behavior in C. According to the ISO standard, if the right operand is negative or exceeds the width of the left operand, the behavior is undefined. In the provided code, the assembly output shows that the shift operation has no effect, indicating this undefined behavior.